In this video, we're going to take the vector drawing that we created in our last video, and we're going to add toolpaths to this so that we are able to bring it over to the CNC router and cut out our custom name plaque. So we start out with our vector drawing, and we want to click on our toolpaths button, which is in the top right hand corner here. Now, if you're having an issue with this window constantly hiding on you, you can click on the little pin right there where it says auto hide, and this will snap on the right hand side, and it won't disappear on you. So our first toolpath that we want to make is going to be a pocket, and what we want is we want this outer edge to be elevated a little bit, and all of our letters are going to be elevated, and this inside is going to be cut down 1/8 of an inch. So to be able to do that, I'm going to come up to our toolpath operations, and I'm going to click on Pocket Toolpath. And in here, we are able to select the different tools that we are going to be using. And for this toolpath, we're going to use 2 different tools. So I'm going to start off by hitting select, and I'm going to select a 1/8 inch end mill. And on here, we want to have a pass depth of 0.125. When we are starting out with our CNC router bits, we generally don't want to have a pass depth that's deeper than the diameter of our tool bit. Our step over is going to be 40%. So in the case of a 1/8 inch tool bit, our step over is going to be 0.05 inches. Our spindle speed, we're going to bump up to 16,000 RPM. And our feed units are going to be in inches per second. So for our feed rate, we want to have for 2 inches per second and a plunge rate of 1 inch per second. I'll click select, and we see that it populates in here. Now, if we were just to use an 1/8 inch end mill, what would happen is it would do a very good job of clearing out this area over here. However, we would have a very difficult time being able to get into all of these tight little corners. So what we want to do is we want to add a second mill bit, and that's going to be a 1/16 inch mill bit, and that's going to allow us to get into all those small cracks and crevices. So I'm going to select, hit select again, and I'm going to select a 1/16 inch mill bit. So again, our pass depth we want to have is the same diameter as our mill bit. So our pass depth is 0.0625. Our step over is going to be 40%. So again, for 1/16 of an inch, it's going to be 0.0248. Our spindle speed is going to be 16,000 RPM. And our feed unit is going to be in inches per second. And our feed rate will be 1 inch per second and a plunge rate of 0.7 inches per second. And we will hit select. Now what we want to do is we want to select both of our vectors. So I'm going to select this outside one first, hold down shift on the keyboard, and select my text after that. Then what I want to do is I am going to select ramp our plunge moves, and we'll just do a distance of, let's say, 1 inch for our plunge move. And what that's going to do is that's going to allow us to move horizontally as our bit goes down so that our bit has an easier cut. So then we'll hit calculate, and you will see a bunch of lines appear. If we'd like to preview this, we can click on Preview All Toolpaths, and the first toolpath that's going to happen is this is our 1/8 inch mill bit. And you can see that's doing a very good job of clearing, but it's not going to get like inside the A or some of the other ones. So it comes back with a 1/16 inch mill bit, and we're able to clear everything out. And there we have our, the inside of that A came out a lot better. So we'll hit close. And on the top here, I want to go back to my 2D view to get back to my drawing. The next toolpath that we're going to do is we are going to do our drilling toolpath. So I'm going to click on my drilling toolpath, and our start depth here is going to be at 0 because that's going to be at the top of our surface. And our cut depth for this is actually going to be 0.52. What this means is that our mill bit is going to drill 20 thousandths of an inch into our bed, so that we can be assured that our mill bit is going all the way through the material. We want to use peck drilling, and then what I want to do is I want to hold down Shift on the keyboard, and I want to click on all 4 of my circles. We'll hit calculate. It may give us an error saying that the tool will cut through the material and it will go into the machine bed. We have a waste or a spoil board underneath this, so that will be okay. So we hit OK. And we can see that now we have our the green tool paths right there show where those holes are going to go. I want to go back to our 2D view, and we have one more tool path that we want to do, and that's going to be cutting out this entire part. So we want to hit close here, and I want to select the outside vector. I'm going to come up to the profile tool path, and for this we're again going to start with a depth of 0, and for Corian we are going to use a cut depth of 0.48. Now with Corian, it's kind of a unique material that it's a little bit brittle, and we aren't going to be cutting all the way through. What we are going to do is we are going to come 20 thousandths of an inch shy of the bottom, and that's going to leave a very fine layer underneath that we'll be able to break through, and it'll actually give us a better finish in the end when we sand that little lip down. We're going to use our 1/8 inch mill bit, so I hit select, make sure that we have that 1/8 inch mill bit, and again just going through all of our different parameters. Our diameter is 1/8 of an inch or 0.125, pass depth again 0.125, step over of 0.5, or excuse me 0.05 or 40%, a spindle speed of 16,000 RPM. Our feed units is going to be in inches per second. Our feed rate will be 2 inches a second. Our plunge rate will be 1 inch per second. So then we hit select. This is going to be on the outside, and what we want to do is we want to do climb milling. And what climb milling will do is it will go with the rotation of our mill bit, and then we want to do a separate last pass. And what that's going to do is that's going to come in, and it will take our final pass will be in the opposite direction, and it's going to come in 0.01 or 10 thousandths of an inch to clean up our edge so that everything is nice and even. Because when we do cut using a CNC mill bit, you will get a little bit of deflection in our smaller mill bits. So what we want to do is our final one, we want to make sure that everything is nice and even, and we take a final trim pass. So we have a 10 thousandths allowance there, and we're going to reverse the direction so that we are doing conventional milling on the way down. We're going to add a ramp to that tool path, and 1 inch should be good. What we'll do is we'll click calculate, and there we see our 4 tool paths. And if we want to preview this, I'll reset our tool path, and we make sure that all of these are selected, and I click on preview all tool paths, and we'll see it start out with our 1/8 inch mill bit. It'll go through, and now it is switched over to our 1/16 inch mill bit, switch back to the 1/8 inch mill bit, cut our 4 holes, and then what happened is we are cutting out the exterior of our sign. Now, to make this a little bit more efficient in the shop, is here this one was made with our 1/8 inch mill bit, 1/16 inch mill bit, 1/8 inch, 1/8 inch. What we're going to do is we're going to take our 1/8 inch mill bit tool paths, and we are going to have all 3 of these go first, and we're going to finish off with our 1/16 inch mill bit at the end. This one is taking a very light trim pass, so what will happen is we will cut all of our 1/8 inch tool paths first, and then we will trim, or we'll switch out our tools to our 16th inch mill bit, and then we'll finish up any fine detail on our part. When we are done with all of this, what we want to do is we want to save our toolpath. So we click on Save Toolpath, and we want to make sure that we have our visible toolpaths to one file. So what's going to happen is I'm going to select all of my 1/8 inch tool, or my 1/8 inch mill bit toolpaths, and if I select my 16th, you're going to see that we have an error that the visible toolpaths use different tools. So I want to select my first 3, and we want to make sure that my ShopBot pulse processor is selected, and I'm going to save my toolpath. Now, when we name this, we have a naming convention. We are going to do your last name. So I'll type in my last name, which is Brill. And then I want to type in which toolpath this is going to be. So this is going to be my first of two toolpaths. So it's going to be Brill 1. And then I want to type in my description of my tool that I'm going to be using. So I'm going to do a 1_8 mill bit. The reason that we do this is when we bring this into the shop, we can't really see the tools or anything that's going to be used until we load up the file. So what you can do is you can use a descriptive file name like this so that we are able to tell what tools need to be put in the router before we start it up, and we know which order that our files need to be done. So I have Brill, that's my first toolpath, there's my bit that I need to be using. We'll press save. So then we need to select the second one, and we're going to save this toolpath, and it's going to be very much like the last one we just did. It's going to be my last name, except this is our second toolpath, so I'm going to type the number 2, and I'm going to do 1_16 mill bit, and then we select save. Now we need to bring those onto a flash drive, and then we will go and mill out our material. Make sure before you close anything down, though, you want to click File Save, and there we have it.